Hello dear students, today we will discuss the Fermi temperature, Fermi velocity and the expression for electrical conductivity based on quantum free electron theory. So in the last class we have discussed about Fermi temperature, Fermi energy, Fermi factor. So today we will discuss what do you mean by Fermi temperature, TF. So the temperature at which the average thermal energy of free electron in a solid becomes equal to Fermi energy at 0 Kelvin is called Fermi temperature. So it is the temperature at which the thermal energy of free electrons should become equal to Fermi energy, and that temperature is called Fermi temperature. It is given as TF is equals to EF divided by K. Then similarly we will define Fermi velocity. So it is the velocity of the electron whose energy is equals to Fermi energy is called Fermi velocity. So you have to find out the velocity of the electrons whose energy is equal to Fermi energy, and that velocity is called as Fermi velocity, which is given as Vf is equals to 2 into EF divided by m raised to 1 divided by 2. So using this quantum free electron theory, using the help of Fermi energy, we are able to find the expression for electrical conductivity based on quantum theory. So by applying Fermi Dirac statistics, Sommerfeld was able to obtain the expression for electrical conductivity of metal, and it is given by sigma is equals to ne square lambda divided by m star into Vf, where m star is known as effective mass. So this is the expression for electrical conductivity based on the quantum free electron theory. Now, what are the merits or the success of quantum free electron theory that we will discuss, which we will call it as merits of quantum free electron theory. So the drawback of classical free electron theory were removed by the quantum theory. So at the beginning we have discussed the classical free electron theory is having the demerits or the drawbacks which are removed by the quantum free electron theory. So what are those drawbacks? The first one is temperature dependence of electrical conductivity. Now all of you know that sigma is inversely proportional to temperature, but according to classical free electron theory, sigma is directly proportional to 1 divided by root of T, which is not correct, because experimentally we found that sigma is inversely proportional to T. Now the quantum theory has explained it. Expression for electrical conductivity can be written as sigma is equals to ne square tau f divided by m, where tau f is equals to lambda f divided by Vf. Since EF is independent of temperature, Fermi energy is independent of temperature, it is not dependent on the temperature. So Vf is also independent of temperature. So dear students, you should understand the Fermi energy is independent of temperature. So the Fermi velocity, the velocity of those electrons, is also independent of the temperature. So only lambda f is dependent. Lambda f is nothing but mean free path of the electrons or the Fermi electrons. So lambda f is dependent on temperature. We know that at very high temperature only electrons closer to Fermi energy get excited. So in the Fermi factor we have observed, when the temperature is increased, the electrons which are close to Fermi energy, they will get excited. Thus only small percentage of electrons close to Fermi energy get excited. Thus only small percentage of electrons contribute to electrical conductivity. This is important. Only small percentage of electrons contribute to electrical conductivity. In the classical mechanics it says all electrons will contribute for the electrical conductivity, but it is not true. it can be shown that at very high temperature lambda f is inversely proportional to temperature. As the temperature increases, the mean free path of the electrons will go on decreasing. Therefore, since this lambda f is dependent on the temperature and this lambda f is inversely proportional, we can say sigma is inversely proportional to temperature, which is in agreement with the experimental results. So this is the first drawback which was explained by the quantum theory, that is temperature dependence of electrical conductivity. Okay, then the second one is dependence of electrical conductivity on electron concentration. How electrical conductivity is dependent on the electron concentration. According to quantum free electron theory, expression for electrical conductivity is given by sigma is equals to n e square lambda f divided by m into Vf. Here sigma is dependent on n. Sigma is dependent on n, but n depends on Ef, Fermi energy, also Vf, velocity of Fermi electrons, and Ef, that is Fermi energy. Thus, there is no direct relationship between sigma and n. In the classical mechanics, we said that if sigma is directly proportional to n, then as the number of n increases, the value of sigma should go on increasing. But in the quantum theory, it explains that sigma is not only dependent on n, it dependent on Vf, and it also dependent on the Ef, and that is the reason as the number of free electrons increases, the conductivity will not increase, because it depends upon other parameters also. So this is the second drawback of the classical mechanics, which overcome by the quantum mechanics, that is dependence of electrical conductivity on electron concentration. Okay, so this completes the quantum free electron theory. Thank you.